MacMaths, let's do some maths today. Okay guys, I've done a lesson just recently on velocity time graphs and I'm now going to go through selected questions to support you doing exercise 9B from the AS Mechanics and Statistics book. That's that one from Pearson. And this is on constant acceleration, and I'm going to go through the even numbers only. You can see I'm just putting the book there by the side of me. So I'm going to go through questions 2, 4, 6 and 8, so it's not too long. You should be able to fill in the gaps from there. It does finish on question 8, so that's going to be the hardest one, isn't it, when we get to that one. Okay, so let's have a look at the first one. Typical, these are, from my experience of exams, the mechanics, the old M1 exams. I say old, it's only a couple of years out of date, isn't it? But it ran for nearly 20 years. These are the typical, the writers at Edexcel, these are typical exam questions. A bit simple to start off with, and then they get harder as the exercise goes on, or this particular exercise anyway. They're all the sort of same in terms of how they start. They describe a situation, and usually they ask you to draw the velocity time graph. So let's have a look at these. This first one here, number 2, so I'm going to start with the even numbers. So number 2 here, just making sure that's in frame. It is. Okay, I don't want to go out the frame at the bottom there. So a car is moving along a straight road when t is equal to 0. So we're going to start with our sort of graph here. So when t is equal to 0, so here, the car passes point A with a velocity of 10 meters per second. When t is 0, so when t is 0, it passes a point it's already travelling at 10 meters per second. So this is the velocity and this is the time. So it's travelling at 10 meters per second, and that's maintained until t is 30. So after 30 seconds, so this comes here. So constant velocity for 30 seconds. The driver then applies brakes and the car decelerates uniformly, coming to rest at the point B where t is 42 seconds. So it decelerates down to this point here at 42. So it starts at A and finishes up at B 42 seconds later. Sketch the velocity time graph. So that's part A. So we've done that. There we go. Give ourselves a pat on the back for that to illustrate the motion of the car. And find the distance from A to B. So very straightforward, this first one, isn't it? You know that this is area, the area underneath the, I was going to say curve there, the area underneath the graph is the displacement from A to B. So let's just do that. Let's not split it up into a rectangle and a triangle. So we're going to go, the area is a half of the A plus B times the height. That's the formula, isn't it, for the trapezium, and that's what we've got here. So that distance is 30, the whole distance, the bottom is 42. So it's the only one I'm going to do this on. We've got 42 and we've got 30 and we've got a distance of 10, and that is our A, B and H. So we put those into the formula. We're going a half of 30 plus 42, which is 72 times 10. Half of 72 is 36 times 10, 360 meters. Okay, and that's the answer to part B. That's how far the car travels in that time. Okay, so that's number 2. Let's get rid of that. Hope you're having a go at these first before. Do the even numbers first with me, and then do the odd numbers. That's the best way of doing this. Number 4 is one that they haven't given you a graph as well. So there it is. This is the bottom of page 135. Doing now number 4, and it says so we're going to have our velocity. It's going to be the same thing, time and velocity. That's in meters per second. This is in seconds. All of these are. They use the SI units. A motorcycle starts from rest at point S. Great. So we're at 0 meters per second here. He moves with constant acceleration for 15 seconds. So that's going to be a straight line going up, and that's at 15 seconds. Let's add a little bit of colour into there. So a dotted line down there. That's what I often do. About a point, I'll leave me yellow there. 15 seconds, reaching a velocity of 30, so we can put that in, 30 there. He then travels at constant velocity of 30 meters per second for t seconds. So over there, that's t. Then decelerates at a constant rate, coming to rest at point F. Down to there, that's point F. He then travels at a constant velocity. He decelerates, yeah, got that, at a constant rate, coming to rest at F, 25 seconds after he begins to decelerate. Oh, I see. Okay, so that section there is 25. Okay, along the bottom. So it takes him 25 seconds to decelerate. That's what it's saying. It takes him 15 seconds to accelerate. So that section there, from there to there is 15. Sketch a velocity time graph. Yeah, we've done that. So that's it. So part A we've done. Given that the distance between S and F is 2.4 kilometers. Okay, so now they're telling us that this is 2.4 kilometers. So the area underneath here has got to be 2.4 kilometers. Calculate the time the motorist takes to get from S to F. So we don't know that time. We do know we've got a 25 and a 15, so we know it's bigger than 40 seconds, but it's got this section missing in the middle, hasn't it? So we've got to work that out before we can add these three together. Okay, so let's do this one. First of all, got to be very careful, haven't we? 2.4 kilometers is 2,400 meters, so we've got to change that, and then we're just going to use the same formula. Okay, the top is t, and the bottom, of course, is going to be, the whole distance is t plus 40, isn't it? That's that section there, plus the 25 and the 15. So we've got area is equal to a half of a plus b times h. So we know that the area has got to be 2400 is equal to a half of, and we've got t plus 40 times h, which is 30. So we've got that. Okay, so that's what we've got to work out. We can, there's different ways of doing this. We could divide the whole side by 30. That's easy enough. So divide both sides by 30. Divide that by 3. Oh, that's nice, isn't it? That's 80. 24 divided by 3, so is 8. So that's right. And then we've got this here. If we go a half of, in the bracket, we've got 2t plus 40. Of course, we could just double that to get 160. But half of all of that is just t plus 20, isn't it? And take off 20 from both sides, and you can see that t is 60. You might do it a different way, but we get to t is 60. So the total time is equal to 60 plus 25 plus 15, so 100 seconds. There we go, and that's the answer we're after. That's what it's asking. Okay, the total time it takes to accelerate, go along and decelerate, 100 seconds. That's question 4. I'm flipping over, I'll just show you. I'm going to go 6 and 8. So I picked the even numbers, could have picked the odd numbers, but the even numbers are the ones where you've got to do that extra little bit of drawing the graph as well. So, and that's really good practice for you to do. Piece of tracing paper fell off there. Okay, so number 6. What have we got here? Sorry, I struggle to read. I only learnt to read a few years ago, so I'm a little bit slow on that. So number 6, a particle moves along a straight line. The particle, we're going to go again, aren't we, here? T and V. The particle accelerates from rest to a velocity of 10 meters per second in 15 seconds. Okay, so this is 10 and that's 15. Let's get my down there. So it reaches 10 here in 15 seconds. The particle then moves at a constant velocity of 10 meters per second for a period of time. Okay, so it goes along here for a period of time. We don't know that. The particle then decelerates uniformly to rest. Okay, so we've got that in. Great. The period of time for which the particle is travelling at a constant velocity is 4 times the period of time for which it is decelerating. So that section at constant velocity is 4 times that section, okay, in terms of time. Okay, get that? So if we call that time there x, then this time here is 4 times that, that's 4x. And this here took us 15 seconds. Yeah, so that works. What's it say now? Sketch a velocity time graph. Yeah. So we've done that. Part A, we've got our marks for that. Given that the displacement from the starting point of the particle after it comes to rest is 480 meters. So it's saying that that whole distance is 480 meters, which means that the area again is 480 meters. So easy enough now. The difficult bit was just deciding that that time is 4 times that, so 4x and x. I regret drawing it so it's a bit sharper, isn't it, to make it look a bit more realistic. So here we go, that top is 4x now, and we are going, what are we going? We're going, again, same thing, area, a half of A plus B times height. The area is 480, a half of A, which is 4x, plus B, all of that, 4x plus x is 5x plus 15, 5x plus 15, times the height, which is 10. That's nice, isn't it? Okay, so first thing I'm going to do is divide both sides by 10, so I've got 48, and all of this is going to be 4x plus 5x, 9x plus 15. Now I wasn't really expecting that. Half of that would be very awkward, so I'm going to double both sides, so I'll get 96 is equal to 9x plus 15. So I've just doubled both sides to get rid of that half, because I can't really half that, and take off 15 from both sides, and the moment I do that, I know that I've got this question right, because what's the chances of that getting a number that divides by 9? Quite slim, 1 in 9 actually. So x is equal to 9 seconds. So what is the question asking? The question for the total time that the particle is moving. So that's the whole bottom, isn't it? So on the bottom we've got 5x. So 5x, so 5 times 9 is 45, 50, 60. So 60 seconds in all. There we go, that's our answer. Okay, so x is 9. 4 9s and another 9 and a 15 makes 60 seconds. That's how much it's travelling for. Okay, so that's number 6. And the last one, number 8. Traditionally, number 8. Traditionally, the last one's the hardest one, isn't it? So that's what I'm expecting with this one, number 8. So let's have a look. And again, it's no. Let's get this ready because there's no diagram, so it's definitely going to ask us to draw a diagram before I've even read it, the question. A motorcycle M leaves a junction at time t is 0. Brilliant there. She accelerates from a rest at a rate of 3 meters per second for 8 seconds and then maintains constant velocity. So we've got, this is M, we've got 8 seconds there on the clock, and this is an interesting one because it says that she is, for 8 seconds she's been accelerating at 3 meters per second squared. So that means the gradient is 3. So for every one along it's going up 3, and it's doing that for 8 seconds, which means it's not telling you, you've got to work that out for yourself. If she's accelerating at 3 meters per second squared, what that is saying is that she's, every second she's increasing her velocity, her speed by 3 meters per second. So after 8 seconds it means she's going to be doing 24 meters per second. Okay, so unusual one, that one. Gives us that. So we take that up to there. And what does she do then? Not a lot, actually. And she maintains the constant velocity, so she's off in that direction. And that's M. There she is. But it says there's another one. Oh, this is exciting. The car, there's another one. A car C leaves the same road junction at T is 0. So at the same time, let's get a different colour now. And let's have a look at this one. So it's saying that the car C leaves the road junction at T is 0. The car accelerates from rest to 30 meters per second, so faster than her. It accelerates, but it does it over a long time. It does it over 20 seconds, so it's going to be accelerating a little bit slower. It's going to reach in 20 seconds there, and it's going to reach 30 meters per second, and then it maintains that velocity, and that is called a car C. That's called C there. Be careful with this one, because the fact that they cross over there does not mean, you know, in the road that's the point where they sort of cross over. The point of where they cross over is when the areas are equal. So this is just one graph, one velocity time graph superimposed onto another velocity time graph. The fact that the actual graphs cross over is not an indication at that point that they cross over, unless of course the areas were the same, but the area of this triangle here would not be the same as this trapezium underneath it. So it's not a point where they're crossing in the road there, so just be careful. And it then goes on to say, yeah, C and M, they both pass a pedestrian. Okay, so they both pass a pedestrian at some point, and C passes M. Okay, so they both pass a pedestrian at the same point. So let's say this is, you know, pedestrian point. So at this point in time, we don't know. They both pass a pedestrian here. Okay. Okay, so how do we do this one? Okay, so let's call this point here. Sorry, that I was just thinking in that time there, and that's what thinking sounds like with me anyway. It does. Let's call this point T here. Okay, let's put, in fact, let's put it in red. You can tell I'm just stalling here. It's a tactic I do in class as well, just while I'm thinking. That is T. And at that point, they both cross the past the pedestrian. So at that point, this trapezium, this orange outline trapezium, has to have the same area as this blue trapezium here. So we're going to put those two areas equal. And what do we know? Well, we don't know a lot really. We know that they both cross at that point. They both meet the pedestrian at that point. We know that that distance from there to there is T. Okay, so we've got that for the base. But now if we look at the top of the trapeziums, for this orange one, so this is for the car C, we know that that distance there is T minus 20. Because it was accelerating for 20 seconds. So this is the constant bit, the top bit is T minus 20, isn't it? Okay. And also for if we look at the motorcycle, then that accelerated for 8 seconds. So that distance there is T minus 8. Okay, T being the total time and 8 being the time it was accelerating. Now we've got two trapeziums, and the trapezium of that one with T minus 8 and T on the bottom and a height of 24 is equal to the trapezium like that, the orange one, where that's T and that is T minus 20. Okay, and that has a height of 30, doesn't it? There. So that's the maths that we're going to do. The two areas have to be the same. That's when they travel the same distance, and that's when they're passing the the pedestrian. Okay, so I'm just checking my thing. I can just squeeze it on here. I'm going to have to be careful how I do this. So I'm going to go, the formula for this would be a half. So I'm going straight to the area equals a half of A plus B times height, doesn't it? That's the formula. So I'm just looking at this bit. So it would be a half of T plus T minus 8 times 24. That's what that would be. And that is equal to a half of T plus T minus 20. That's the bottom plus the top. Done it the other way around this time for some reason. Is 30. If I get rid of me half and me 24, so I've got the half and the 24 is 12 of 2t minus 8. I'm sure you're okay with me doing that. So that's 15 of 2t minus 20. Okay, so I'm up to that point now. Okay, so yeah, I mean, let's just multiply it out. So let's go 12 times 2t is 24t minus 96. I don't know whether this is the best way of doing it, but I'm doing it this way. Is equal to multiplying that out, 30t minus 300. So I've done the 15 times the 20 is 300. Taking it all over to this, so 24t off both sides would leave me with 6t, and adding 300 onto that, so I've got minus 96 plus 300, 300 minus 96 is 204. Where's my calculator? Does that divide nicely by 6? I hope so. So 204 divided by 6 is 34. So t is 34 seconds solving that. Now the question is to find the distance that it travels. So we don't want the time, we want the distance that it travels. So if we stick 34 into one of these, so yeah, let's just put it into here. 2 times 34. 2 times 34 is, so I'm just putting it, I can put it into either of these. In fact, this one's easier, isn't it? 2t minus 8 times 12, if I put it into that sort of simplified version there. So I'm just, that's all I'm doing. So 34 times 2 is 68, take away 8 is 60, 60 times 12. Oh, 60 times 12. So that's easy to work out. That would be 720 meters, he says. Not hard, it's not easy at my age. Okay, so that's the answer to that one. It travels 720 meters. Okay, I hope you're okay with that. That was the hardest one. Do those even ones first and then have a go at the odd ones. My class, message me if you get stuck on any one of those, and I'll do a little private vid and send you the link for it. Okay, but those should set you up nicely for the 1, 3, 5 and 7. Okay, over and out.